Welcome to Operations with Rational Functions. We will be adding, subtracting, multiplying, and dividing algebraic fractions. Before we get into adding and subtracting, let's review adding and subtracting regular fractions. We need common denominators before we add or subtract. So we will multiply the numerator and denominator by 5 in this case so that we get a denominator of 20 over here on the other fraction. Now we'll rewrite the question here. We have 7 over 20. That's the original first fraction. And then the second fraction becomes 5 over 20. That's an equivalent fraction. We haven't changed the value of the fraction. We just changed the way it looks. Then we subtract across the numerator, keep the same denominator, and we can divide both of these by 2. So we go ahead and simplify and get 1/10. With rational expressions, we'll be doing more or less the same thing. Here are the steps. We'll go through those quickly. We'll be getting common denominators. We'll be combining the fractions into a single fraction with that common denominator. And we'll simplify in the numerator. And then we'll reduce or simplify the whole fraction. So here we're adding two rational expressions. They do not have common denominators. Here we have a trinomial, and in this case, we're hoping that n plus 8 is one of the factors of this trinomial. So let's check. So we're trying to factor n squared minus n minus 72 into two binomials. We want two numbers that multiply to make negative 72 that have a sum of -1. Well, that would be -9 and 8. So we'll rewrite the first fraction as 8 over n minus 9 times n plus 8. Notice one of the factors here is n plus 8, which is the denominator in the other fraction. Now we can think of that n plus 8 as having parentheses around it. And let's go ahead and rewrite it over here. Now to get a common denominator, all we need to do is multiply the numerator and denominator in the second fraction by n minus 9. And now we have common denominators. So let's go ahead and combine these numerators as we add the two fractions. And while we do that, let's go ahead and distribute that 2. All right, so we are adding the two fractions. And when we do that, we get the same denominator. So in the numerator, we'll have 8 plus 2 times n, which is 2n, and 2 times -9, which is -18. A little bit of simplifying to do up here in the numerator. So we'll combine like terms. 8 minus 18 is -10. So we have 2n minus 10 over n minus 9 times n plus 8. Now let's go ahead and fully factor the numerator just to make sure that we don't have one of these factors in the numerator. So we can factor out a 2 from both of these terms. The 2 comes out front. 2n divided by 2 is n, and -10 divided by 2 is -5. All right, we have it fully factored. There's nothing else we can cancel, so that is our answer. Very similar problem, but this time we have a subtraction problem. So we're hoping z minus 6 is a factor of this trinomial, so let's check. So I rewrote the first fractions, so it looks a little different, but it's still the same fraction. They're equivalent. And sure enough, z minus 6 is a factor of this original trinomial. So to get common denominators, all we need to do to the second fraction is multiply by z minus 7 in the numerator and denominator. So we'll simplify across the numerators. We combine the two fractions. Let's see, let's go ahead and add the opposite. So we'll add the opposite. Might be a good way to handle that. So we have -3 times z and -3 times -7. I will simplify that numerator. We have some like terms. So we have -3z plus 22. The numerator and denominator are fully factored, so we have our answer. Before we multiply rational expressions, let's review multiplying regular fractions. So the 15, we could rewrite that as 5 times 3. The 22, that's 11 times 2. Well, the 2, we'll just have that there. And 21 is 7 times 3. Okay, since we are only multiplying, there's no adding or subtracting in this problem, we can go ahead and already start canceling. So we have 2 divided by 2 is 1. 3 divided by 3 is 1. Leaving us with, let's see, there's a 5 in the numerator and 11 times 7 in the denominator. So multiplying rational expressions is a little bit simpler. First, we factor the numerators and denominators and then simplify. Okay, let's give it a try. In the first polynomial, this is a difference of two squares. So if you're familiar with that pattern, you can quickly factor it. You can also factor it with a diamond. We're looking for two numbers that multiply to make 64 that add up to 0, because in between here would be a 0k. So that would be 8 and negative 8. So k squared minus 64, well, that's k minus 8 times k plus 8. Right, now the adding and subtracting signs here are inside of our factors. So we don't have to worry about those as far as canceling, as long as we're canceling factors. So let's look to see if we have any common factors here. Well, let's see, we have a pair of k minus 8s. We have a pair of k plus 6s. And that looks like about it. We'll go ahead and leave it in the fully factored form. Always check your directions to make sure that you don't need to multiply these binomials. All right, these polynomials look quite a bit different here, so we'll be factoring them differently. This is not a difference of two squares. Instead, we are going to factor out a common factor. They're both divisible by 8m. The 8m comes up front. 16m squared divided by 8m. 16 divided by 8 is 2. M squared divided by m is m. We have our subtraction sign. 24 divided by 8 equals 3. And m divided by m equals 1. In the denominator, let's go ahead and factor out a 4. Both of these terms are divisible by 4. That 4 comes out front. 4m divided by 4 equals m. And 32 divided by 4 equals 8. That's plus 8. Let's continue our factoring. Right, all the addition and subtraction signs are buried inside of the factors, so we can go ahead and start canceling because this is a multiplication problem. Here's a pair of 8m's. Here's a pair of 4's. And that looks like everything. Let's review dividing with fractions. The easiest way to divide with fractions is to just multiply by the reciprocal. So let's rewrite this as a multiplication problem. 3/8 times 44 over 27. So same question, just looks different. This 8, I'll rewrite that as 4 times 2. The 44, I'll rewrite that as 4 times 11. And the 27 as 3 times 9. 3 divided by 3 equals 1. And 4 divided by 4 equals 1. Multiplying across the top, we get 11. And 2 times 9 equals 18. So here's some steps for dividing. Sometimes we might want to rewrite the question so it looks a little bit different. We'll do that if necessary. Then we're going to multiply by the reciprocal. Then we do our factoring, and then we simplify. This looks a little different, but let's think of this fraction bar in the middle like a division sign. So let's go ahead and rewrite this using that division sign. So here's that fraction that was in the numerator. I've got that fraction written here. Now I'm writing my division sign. And now I'm going to write the fraction that's in the denominator. Okay, this looks more doable now. So let's go ahead and multiply by the reciprocal. I'm rewriting the first fraction. All right, we're hoping this trinomial here will be factorable into two binomials. Same thing here. There's no guarantees they are. We'll have to check. This looks like a difference of 2 squares. So that will factor into two binomials as well. And hopefully that trinomial factors into the product of two binomials. All right, let's start with this first one here. Let's go to the fraction in the denominator. Then we'll go to this difference of 2 squares. If you're comfortable with that shortcut, we see that it's just y minus 3 times y plus 3. You can always do a diamond problem with a 0 in the bottom there. But let's go to the trinomial in the denominator. Right, all of the addition and subtraction signs are buried inside of factors. So we can go ahead and start canceling since this is a multiplication problem. So we have a pair of y minus 9s, a pair of y plus 3s, and that looks like everything. Once again, we will rewrite this fraction bar as a division sign. Now we can rewrite it as a multiplication problem by multiplying by the reciprocal. Looks like we can factor out a 2 or 5z from those two terms. And in the denominator, we can factor out a 4. So we're down here, so we factored out a 4. Up here, we can factor out a 4 as well. And down here, we can factor out a 5z. Everything's factored. It's a multiplication problem. We can start canceling. 5z divided by 5z equals 1. 4 divided by 4 equals 1. And that's everything. I hope these examples have been helpful. This is Mr. Rila, signing off.